Hey guys, welcome to Unit 5 Lesson 2. Today we are going to be starting our limits lesson, finding limits graphically. So I want you to pause the video and try the warm-up on your own. So number 1 says, consider the graph of the following function. So you're given a rational function and you have subparts to it. It's asking part A, are there any values of x for which the function is undefined? So remember, anytime we talk about undefined, think about when is a fraction undefined? Whenever we get a 0 in the denominator, right? So same thing here. This is a rational expression. So when would this be undefined? When my denominator, I really don't care about my numerator, when my denominator is 0, right? Or anything I substitute for x that makes it 0. So what would that be? So what do? X minus 4 equals 0, set it equal to 0 and solve. So x equals 4 will make my denominator 0. So what are the x values? It is 4, right? And it says why? Because it makes my denominator 0. It makes the denominator equal to 0. Part B says, enter the function into your graphing calculator and using the table set, begin your table at x equals 3. So you want to start your table at x equals 3 and set the change table to 0.1. Use the values given to fill in the table below. So do that. I am going to fill this in the y values, and this is what I got. And at 4 we got an error, which we actually determined here also, right? At 4 we would have an error, or it's undefined. So now what's happening at explain in your own words what's happening at x equals 4. So this is where we actually need to pay a little more attention. Look at the values from the left, right? What number are they approaching? They're approaching basically 3. If I changed my table to 0.01, and you'll see it even more clearer. So what numbers is it approaching? So y is approaching, isn't that the y value is approaching? Sorry about the bell. Approaching 3 on both sides. Number 2, it says consider the graph of the function f of x, and it's given to us and it's asking us similar questions. A says, are there any values of x for which the function is undefined? Again, what x value makes my denominator 0? It is 1. Oops. It is 1, right? And now it's asking us to fill in this table below and change your table to 0.1 and start your table set at x equals 0. So pause the video. So I filled in the values, and look here. It's saying, asking us in part C, explain in your own words what's happening at x equals 1. So look at this around here. From both sides, from the left and from the right. Isn't it approaching, isn't y approaching the same value? So approaching, or y is approaching, what is it approaching? 0.5 on both sides. So you have to check both sides, right? So that's what it is. It doesn't matter to us that it has an error at 1, but we're seeing what values it is what value is it. Now let's look at this. What is limit of a function? In mathematics, the limit of a function is a fundamental concept in calculus. A limit is a certain value to which a function approaches. Finding a limit means finding what value y is as x approaches a certain number. So basically, limit is your y value. So this is very, very important. I want you to understand that. Okay, so all I'm asking you is, when x is a certain number, what's my y? How is my y behaving? And that helps us understand more things. We're only, and this is the notation, I will read it to you how we read it as limit as x approaches c, f of x equals L. So please read it carefully. We are only concerned about what happens with f of x, which is your y, as x gets arbitrarily close to See, we don't actually care about what happens when x is equal to c. We're just worrying about what's happening when we are getting close to that certain value. So how do we find limits? There are few ways we can find limits. There are several methods that can be used to find limits. Graphically, we can approach a given value from the left, which will give us the left-sided limit, or from the right, which will give us the right-sided limit. So this is your first method. So if the limit exists if left side limit is equal to the right side limit. So let's do the question. First of all, this is not, oh, hold on, let me highlight it. This is not negative. This means from the left, as you're approaching y from the left. Okay, so, or I would say as x is approaching 0 from the left. Let's write that down. As x is approaching 0 from the left. That's how you read it. Okay, so what is f of x? So I'm going to trace it. I always like to trace them. So as I'm approaching 0 from the left, what number am I approaching? It is 1, right? That's my y value. So now this means from right. Okay, on top of it, on the top right corner, it is from the right. So I'm going to trace it in blue. From the right, look at your graph. As x is approaching 0 from the right, what is my y value? It is 1, 2. So now, are these two same? Are they same? They both are same. So answer is my part C. So does limit as x approaches to 0, f of x, it does exist, and it is what? 1. If they weren't same, we'll see what happens. And what is f of 0? Now look at this. This is an empty circle, but this is a filled one. So that is f of 0. So when x is 0, what's my y value? Which is 2. So be careful with that, okay? So let's try the next one. Again, this means what? Left. And this means right, as you're approaching from the left and right. That's what it means. So limit as x approaches 3 from the left, I'm going to trace it. 3 from the left, this is this, right? What y value am I approaching? It is 3. That's 3. Now, limit as x approaches 3 from the right. 3 from the right, this is my graph. I'm going to trace my graph. I'm literally tracing. What is my y value? It's approaching this number. What is that number? Negative 2. So, negative 2. Now, are these same? No, they're not. So, limit as x approaches 3, f of x is, it is d and e, which means does not exist. Why? Because these two limits are not the same. But and part D is f of 3. So at 3, what's my filled circle? It's at 1. So do we understand that? If not, please ask me questions. I hope it's very straightforward. There's not more to explain, but it's very straightforward. You're just looking at how y is behaving or what's happening to y. Okay, so that was the first method when you look at graphs and determine if the left side limit is equal to the right side limit. Now by direct substitution, we can find the limits of polynomial functions and most rational functions by using direct substitution. Find the limits for each of the following. So all you do is limit as x approaches 3. All you do is take 3 and substitute for x, right? So 2 times 3 plus 4, which is what? 10. That's what it is. B. So here limit as x approaches negative half. It's just direct substitution. So wherever you see x, all you're going to do is substitute negative half. That's what you're doing. 2 times negative half minus 1. So what do I get? This would be 3 times. You can put that in the calculator or do it in, I would say do it in your head. This should be what? Negative 1 minus 1, which is negative 2. Negative 2 times 3 is negative 6 over 4, which is same thing as negative 3 halves, right? So the next one, x approaches limit as x approaches 2. So substitute 2 into it. 2 squared plus 5 times 2 plus 6 over 2 plus 2. My denominator is 4, 2 squared is 4, 5 times 2 is 10, 14 plus 6 is 20, 20 divided by 4 is 5, right? So now I want you to finish the remaining problem set, and good luck. If you have any questions, reach out to me.